One thing that propositional calculus is very useful for is giving us a way to analyze arguments and see why they're true or not. So in this section, we're going to have a look at some logical fallacies and fairly common forms of invalid arguments. So let's start out with fallacies. So a fallacy is an error in reasoning that gives us an invalid argument. And we have three common types of fallacies. The first use ambiguous premises. So this is really saying we're using ambiguous assumptions and treating them as if they're clear. Then the next two are assuming what is to be proved without having actually derived it. So you assume the thing is true and then prove that it's true. And then finally, jumping to a conclusion without actually doing any work. We're also going to talk about converse and inverse errors, which give rise to arguments that look kind of like modus ponens or modus tollens, but are not in fact valid. Okay, so let's start out with looking at a fallacy that uses ambiguous premises. So here we have an argument. There's a premise that a feather is light, and another premise that what is light cannot be dark, and then we have a conclusion. Therefore, a feather cannot be dark. The problem here is that we're using the word light in two different ways. So this is our ambiguous premise. We're meaning, so in the first sentence, we're probably meaning that the feather is light, meaning it weighs a little bit, only a little. But our second premise is what is light cannot be dark. Here we're using light in a different sense, in terms of the opposite to dark. And so there's a kind of a conflict between how we're using the word light, and our argument becomes invalid. Another example, which is fairly common, is something like the following. Because it's called the theory of evolution, evolution is no more than an unproven assumption. And the idea here is the use of the word theory here is an incorrect definition of the word theory. Two other examples of fallacies. Assuming what is to be proved. For example, abstract art isn't even art. Those pictures and sculptures don't represent anything, and that's how you know it's not even art. So here, you're making the assumption that abstract art isn't even art, and then you have some pictures and sculptures that don't represent anything, i.e. they're abstract, and therefore they're not even art. But the problem is, this is the thing that you're trying to prove, and you've stated it initially as a premise that you're going to work with. The other kind of fallacy that we can look at is jumping to a conclusion, which is just saying something like, people nowadays only vote with their emotions instead of their brains. Well, okay, where's your proof? There isn't any, so you've just jumped straight to that conclusion without backing up your reasoning with any kind of logic or data. But now we look at two kinds of errors, converse and inverse errors, which look very similar to modus ponens or modus tollens. So here we have a converse error. Let's have a look. If Zeke is a cheater, then Zeke sits in the back row. Zeke sits in the back row, therefore Zeke is a cheater. So let's analyze this and see what's happening. So we've got an if then. So we're going to call Zeke is a cheater is going to be our premise, and Zeke sits in the back row, so that's going to be our conclusion. So that's our first thing that we're stating that's true. If P, then C. So our proof goes if P, then C. And the next thing that we state is that Zeke sits in the back row. Okay, so that's saying that our conclusion is true. And then finally, we're concluding that Zeke is a cheater, so we're concluding that P is true. So this looks almost like modus ponens. So remember, our modus ponens says P implies Q and P implies Q. But here we're saying P implies a conclusion, and then we're saying the conclusion is true, not that the premise is true, and then we're concluding that the premise is true. So this is false. Because this would be implying that P implies Q is equivalent to Q implies P, but we know, we've already looked at the truth tables, that this is not the case. And these are quite subtle, because it can sound so much like modus ponens. But if you write it out logically, then you can see where the error is. So this fallacy underlying this particular invalid argument, it's called the converse error because the conclusion would follow if the converse of the premise was used and was true. But remember, we saw that the converse is not always true. Here's another kind of error, which is called the inverse error. So let's have an analysis of this. So our first statement says, if interest rates are going up, stock market prices will go down. So this is an if-then. So we've got our premise and our conclusion, which is then stock market prices will go down. So I'm going to call that Q. So this first step is saying P implies Q. Our second thing says interest rates are not going up. Okay, so our interest rates are going up was P, so interest rates not going up is not P. And then our conclusion is not Q. So the argument here is going P implies Q, which is our premise. Our second premise that we're making is not P. And our conclusion is going to be not Q. But if you remember, this is saying this would imply that P implies Q is equivalent to not P implies not Q, but we know that this is not true. Okay, we know that P implies Q is equivalent to not Q implies not P, but not the other way around. So this fallacy, which is called an inverse error, is called this because the conclusion of the argument would follow if the premise P implies Q is replaced by its inverse, i.e. not P implies not Q. So, however, we know that these are not equivalent. And sometimes this is called the fallacy of denying the antecedent, which is a whole bunch of big words. Now let's talk a little bit about validity and truth. So it's important to realize that an argument being valid and an argument being true are not the same thing. Sometimes if you have a valid argument, people can assume that the conclusions are true. And likewise, sometimes if an argument seems wrong or fishy, then they assume that the conclusions are false. But this is not correct. So you can have a valid argument whose conclusions are false, and you can also have an invalid argument, but the conclusions can still be true. So let's have a look at some examples. Okay, so here we go. If John Lennon was a rock star, then John Lennon had red hair. So here we've got P implies Q. And here we're assuming, so that was our first thing, we had P implies Q. The second thing we have is that John Lennon was a rock star. So that says that P is true, and therefore our conclusion is that Q is true. Now, let's work through these. Are the premises true? So what we want to ask is P true and is Q true? Well, P is true, John Lennon was a rock star, but John Lennon did not have red hair. You can Google that if you want to check. Is the conclusion true? Well, our conclusion says that John Lennon had red hair, and that's false. However, is the argument valid means, is it a logically sound argument? And notice that it is. Our first statement says P implies Q. Our second argument says P is true, and then our conclusion correctly says that Q is true. So this is a valid argument. It's just that one of the premises were true, so overall it's kind of silly. But the argument itself is valid. So the argument is valid, but the conclusion is false. Now let's have a look at the other situation. Again, we've got if New York is a big city, so we've got a premise, then New York has tall buildings. Okay, so here we have, again, a P implies Q. Our second premise is that New York has tall buildings. So that is saying that Q is true. And our conclusion is that P is true. So we have P implies Q. Q is true, therefore P is true. Now hopefully some alarm bells are ringing, but let's work through this. Are the premises true? Well, New York is a big city, so our P is true. And New York definitely has some tall buildings, so Q is true. And the conclusion is also true. New York is a big city. But notice that this is not a valid argument. This is one of the examples that we've seen of an invalid argument. And because we have to, if we've got P implies Q, to have a valid argument, we need to have P true, not Q true. So here's an example where everything is true, the premises are true, the conclusion is true, but the argument is invalid. So hopefully these two examples will have convinced you that there's a difference between truth and validity. And if someone is making an argument, it's worthwhile kind of spending some time thinking about whether their argument is valid or invalid, and then also thinking about whether their conclusions are true or not, because these things are not necessarily connected. So here's something for you to test yourself on. We want to decide if an argument is valid or not, and if it's invalid, does it exhibit a converse or an inverse error? So I'm going to use symbols to write the logical form of the argument. So I would suggest that you stop the video for a moment, see if you can do it, and then come back and check. So let's have a look and see. If this computer program is correct, then it produces the correct output when run with the test data that my teacher gave me. Okay, so this is the first thing that we have is an if then. So if this computer program is correct, then it produces the correct output when run with the test data my teacher gave me. Okay, so this first line says P implies Q. Our second line says this computer program produces the correct output when run with the test data my teacher gave me. So this is saying that Q is true, and therefore it's concluding that P is true. So we have an argument that says P implies Q, Q is true, therefore P is true, and we know that this is invalid. And if you go back and check, you should go and check if this is a converse or an inverse error. So you'll have quite a few of these to work through, and the idea here is that we're using all the logic that we've developed so far to actually be able to talk sensibly about arguments, whether in computer programs or just in everyday life. We now have the technology that we need in order to be able to discuss whether things are valid or not.